So imagine you are running MySQL database in the Kubernetes, and if the pod is deleted, how do you make sure the data is not lost? And how does the new pod come back with the same identity? And the answer is StatefulSet. So in this video, we will cover what is StatefulSet, how it is different from the deployment, how it works, and we will also deploy MySQL StatefulSet on the real Kubernetes cluster. So let's get started. So what is StatefulSet? So a stateful set is the Kubernetes workload that is used to manage the application that need to keep their identity and data. So unlike a deployment where pods are temporary and interchangeable, a stateful set gives each pod a fixed name such as Web 0, Web 1 and Web 2. It also gives you persistence storage and a stable network identity. Example include database like MySQL, PostgreSQL, MongoDB, and application like Kafka and RabbitMQ. Now, how does the stateful set is different from the deployment? Now let's understand the difference. So both manage the pod, but they behave differently. So in the deployment, pod name is random such as nginx and have some suffix. But in the stateful set, pod name are predictable like MySQL 0, MySQL 1 and MySQL 2. In the deployment, all pods are created in parallel. But in the stateful sets, pods are created one at a time or in order. In the deployment, storage is optional, usually shared or temporary, but in the stateful set, every pod gets its own persistence volume claim. In the deployment, pod identity does not matter, but in the stateful set, each pod keeps their same name, same storage, same network identity even after deleted or recreated. Now let's see how stateful set works. So before creating the stateful set, we first create the headless service. So unlike a normal service, headless service does not provide the single IP address, but it gives you each pod with own unique DNS name that allow to communicate with a specific pod directly. And then after we will create the stateful set. And this YAML file create MySQL application that need stable identity and persistent storage. And the service name connect to the stateful set to the headless service, which provide a stable DNS name for each pod. The replica 3 which creates 3 MySQL pods like MySQL 0, MySQL 1 and MySQL 2. The selected tells Kubernetes which pod belong to stateful sets and the pod templates define how each MySQL pod should create and run with MySQL 8.0 Docker image. The environment variable set MySQL root password when the container start. And the volume mount connects MySQL data directly to the persistent storage so data is not lost. And finally, volumeClaimTemplates automatically create a separate persistence volume claim for each pod. And if pod is recreated, Kubernetes reconnect the same storage, ensuring the data remains available. So in this lab, we will deploy MySQL stateful set and explore its features such as a stable pod name, order pod creations, dedicated storage, a stable DNS name, and persistent data. Now let's create the stateful set on the real Kubernetes cluster. So we will open the killercloud.com. And we will select the Kubernetes playground and we will wait for the environment to load. So let's verify the cluster now. So first we'll create the headless service. So let's create the headless service file. Press -I for the insert mode and paste the YAML file. Now let's execute the YAML file. And let's create the stateful set. And to create the stateful set, so first create the YAML file and press -I for the insert mode and paste the YAML file. Press :WQ and save and exit. And let's apply this file and let's check the stateful set. So our stateful set is still creating. Let's check the pod. And you will see all of the pod has been created and notice the pod are created one by one and that is in order. So first MySQL 0 has created, then MySQL 1 and then MySQL 2. Now let's check the PVC which is automatically created by stateful set. And here you will see there are 3 PVCs running and each MySQL pod get own persistent volume claim. Now let's also check the persistent volume. And we have also 3 PVs running. Now it's time to test the DNS and we are going to launch a temporary BGBox to test the DNS resolution. So we will run this command to create the pod and our pod has been created. Now let's run the nslookup command. Let's run another nslookup command for MySQL 1 and let's run for MySQL 2. And you see each DNS name resolve the different IP address because MySQL 01 has a one pod with own IP. Then MySQL 1 has another pod with a different IP, and then MySQL 2 has another pod with a different IP. Exit from here and let's try to connect the MySQL pod. And so we have connected to the MySQL pod and then log into the MySQLs. Now we are inside the MySQL cells. So let's create a database and table to store the sample employee record. And our record has been created. Now let's exit from here and delete the pod. So our pod has been deleted. Now StatefulSet immediately notice and it will try to recreate the pod. And you see our pod has been created. Now let's log into MySQL 0 pod again and try to verify the data which we have created. Log into MySQLs and then run this query to get the output. And you see even after recreating the pod, data is still available because the same persistent volume was reattached. So let's exit from here and then we will try to verify the deletion order. So for this we will make replica set is equal to 0 and then you will see how the pod is deleting one by one. And you notice the pod is terminated in the reverse order, that is MySQL 2, MySQL 1 and then MySQL 0. And we have successfully completed the demo. So let's clean up all of the stateful set and service which you have created. So let's quickly recap what we have learned today. So the stateful set provides stable pod names such as MySQL 1, MySQL 2 and MySQL 3. Order creation will be MySQL 0, 1, 2, 3. And deletion would be MySQL 2, 1 and 0. A stateful set also provides persistent storage. And this stateful set is the perfect example for the database such as MySQL, PostgreSQL, MongoDB, Kafka and any workload where identity and data matters. And below are the key commands that we have used today. So that's everything about the stateful set in the Kubernetes. So in the next video, we will learn about the Kubernetes job. And if you have any questions, feel free to ask in the comment below. Thanks for watching and I will see you in next video.